Good morning, everybody. Today we are discussing the type of reversible electrode, which I already discussed in the live classes, but I think due to some technical error, many of them couldn't attend the live classes because of some network issue. That's why I am repeating the class here. So, the type of reversible electrode. So, reversible electrode can be classified into the three different category. First one is electrode reversible with respect to cation. For example, zinc rod dipped in zinc sulfate solution. So here, zinc rod is dipped in zinc sulfate solution. So here it is represented as zinc slash Zn2 plus, and it is a normal electrode as we discussed in the galvanic cell, Daniel cell, etc. So the next category is the electrode reversible with respect to anion. So here the example is the silver electrode. In the silver electrode, in the previous case, that is electrode reversible with respect to cation, one electrode that is in the elemental state, that means zinc electrode is dipped in its salt solution. But in the case of the anion, we cannot directly dip that electrode into the solution. For example, in the silver electrode, we are measuring actually the Cl minus ions potential due to the Cl minus ions. So we cannot dip the chlorine as in the case of the zinc bar Zn2 plus, because chlorine is a gas. That's why in that cases we are making the half cell by passing the chlorine gas to an external support. Usually we are using platinum electrode. Platinum, it is an inert support, and we are passing the chlorine gas through platinum support. And here the salt solution is AgCl, and we know that AgCl is sparingly soluble in water. That means AgCl partially dissociate to form Ag plus Cl minus ions, and most of the salt is remain insoluble in the solution itself. So during the chemical reaction, what will happen? During the chemical reaction, this is the silver electrode. See here, in the silver electrode, the chemical reaction occurs is that AgCl accept one electron and converted into Ag, that is silver, plus Cl minus ion. So thus we can measure the amount of the Cl minus ion present in the solution. That means if you know the amount of the ion which is transferred for making Ag plus to Ag, then we can calculate that much amount of the energy is released during the conversion of the Cl minus to. From that we can calculate the measurement of the Cl minus ion. And the cell is represented as Ag slash AgCl slash KCl. And this is the simple representation of the silver electrode, in which there is a silver wire which is coated with an AgCl, and the entire electrode is filled with a solution of the KCl bar AgCl. Either we can use KCl or AgCl, and this is the simple representation of the silver electrode. So the next example is the calomel electrode. As we discussed earlier, calomel electrode contain Hg and Hg2Cl2 plus Hg paste. Here also, as we discussed in the zinc bar Zn2 plus ion, we cannot directly dip the mercury in its salt solution, because we know that mercury is in the liquid form. So, and this calomel electrode also we are measuring the Cl minus ions, and it is a reversible electrode with respect to anion. So the chemical reaction occurs is that Hg2Cl2 plus 2 electron gives Hg. That is, Hg is in the elemental state, and the chlorine is also in the ionic state. Thus we can measure the Cl minus ion potential. Okay. Now next variety is the redox electrode, oxidation reduction electrode or redox electrode. So in which this is the third category in which we are using the electrode as Fe2 plus bar Fe3 plus electrode. That means here we use the support as platinum and which is an inert, and the solution which containing Fe2 plus and Fe3 plus mixture. So what is the chemical reaction occurs? In the Fe2 plus Fe3 plus accept one electron and it is converted into Fe2 plus, and similarly Fe2 plus oxidized to give Fe3 plus plus 1 electron. Then how we can construct the cell using this half cell electrode? That means the oxidation reduction electrode, it is only a half cell. Then how we can construct a cell using this redox electrode? So this is the simple representation of the cell using the redox electrode. And here we can see that as in the normal case of a cell, we have two electrode half cell here. So first one is the redox electrode, that is a mixture which containing Fe2 plus and Fe3 plus ion, and a platinum wire is immersed in the solution. Next half cell is the normal reversible electrode with respect to cation. That means iron rod is dipped in the iron salt solution. So what is the chemical reaction occurs? During chemical reaction, in the half cell which is in the right hand side, Fe2 plus converted into Fe0, that is Fe is in the elemental state, whereas in the half cell in the right hand side, what happened is Fe2 plus converted into Fe3 plus plus 1 electron. And this mechanism is used in the flow battery. I hope that you understood the concept. Thank you.